I'm going to go through some delta problems to help you with the assignment. Um, I've had to look through some of these. Some of these are a little strange, not gonna lie. I've seen ones that they did not know they put. So I'll go through a couple of these to make sure you're on the right track. First thing you want to do is make sure that it says differentiable and continuous, right? If it's differentiable plus continuous, okay, that's the first step. And if the answer to that question is no, then the answer is either, because you don't know either way. It could be true, it could not be true. If the answer to that is yes, then you're going to keep going. Okay. So here it says it is differentiable and continuous. There exists a value c such that derivative of c is 3. Okay, so then basically then this is like find AROCs of intervals. That'll be the next step. So here in this problem, I'm gonna eyeball it. So you'll basically get super good at this so that you can just read it and you won't have to like you won't need to like necessarily find the AROC up by hand. You'll be like, oh yeah, I see it. So here I see I'm looking for 3. Okay, so yeah, this is 3 right here. See how it's going up 3 here? It's going from 11 to 14. It's going from -2 to -1. So I can see, okay, so I would say, 14 minus 11 over -1 minus -2, that's 3 over 1, and so that matches, right? So if it if an interval matches, it's guaranteed. It is true. Okay. If it does not match, no match, then it is either. Okay. So this one is going to be true. Let's do another one. It is continuous and differentiable. I see that. Determine the ability of the following statement. There exists a C. Okay, so it's saying 6. So since it's continuous and differentiable, I go to this step. I find the AROCs. I look for an AROC of 6, and I can tell you by looking at it. Oh, I see one right here. See this? This is not 6 right here. This is 15 over 3. This is 5. But from here to here, it's up 6, up 1. So that's true, because that is an AROC of 6 right there. Let's do a couple more in case there's any weird ones. Continuous and differentiable, so it meets that. Same thing, it's kind of same question. So we're looking for -9 over 2. So going down, these are all going down. This is going over 2, down 8. That's not going to work. This one's going down 10 over 2. That's not going to work. And the last one, this is going over 4, down 18. That's the one. So make sure to check all the intervals. So in this one, see how it's going 3 to -15. That's -18. -2 to 1 is 4, so it's -18 over 4, which is -9 over 2. So that this is also true. Yeah. So this one, I think this is one of the weird ones that I was seeing. Selected values are shown below. Okay, differentiable. Okay. Also, there does not exist a value c in the interval 1, 5 such that the derivative of c is -4. Okay, determine validity. So this is like, this one does not follow this chart. Basically what this is saying is if it turns out that one of these average rates of change is -4, then this must be, hang on, also there does not exist a value, then this must be false. Because if it's continuous and it's differentiable and an average rate of change is -4, then this one must be true. That makes sense? It's like if it's differentiable and continuous and an AROC equals -4, then it must be true. But it's telling me here that it's not true. So that means that it must not be continuous. So here I see it's going. This is 4. It's down 16. There is an AROC of -4. I see it here. This must be false. It cannot be continuous, because if it were continuous and it were differentiable, then this statement here must be true. But it's telling me it's not true. So therefore, continuity must be false. Okay, got the gist of it? Do we need to do more? Um, this is the same thing. Okay, you got the gist of it. -2. No, yeah, it's true because this is -2 right here. It's over 1 down 2. It's true. Yep. Okay. So whatever you do, understand it before you do it. Let's take a look at finding C. All right, with finding C, I did this in class, but I'll do it again. This is the same for calculator, no calculator. It's the same steps. It's IROC, then it's derivative equals AROC. I mean, it's kind of just 2 steps. Find AROC, then say the derivative equals AROC. So here, AROC is going to be f of 1 minus f of -2 over 1 minus -2. So it's going to be a 3 on the bottom. F of 1, so I plug in 1, so 1 minus 5, -4, minus 17, -21, plus 41 is 20. Plug in a -2, -8, 4, -28, -28 plus 34, 6 plus 41, 47. I'm gonna do this one to make sure. I think that's right though, because that'll get me um, -9. But I'll double check this one. So again, just do this in the calculator. You know, if you're not feeling it, so you can just like kind of plug it back in. -2 to the third minus 5 -2 squared minus 17 -2 plus 41 apparently is 87. Okay, so good thing I checked that. Um, I don't know if this is right, because it should be -8 minus 20 plus 34 plus 41. I don't know why that's getting 87. Like I'm looking at that. I don't see how that's getting, how in the calculator it's getting 87. I'm not seeing it. It's somehow it's finding another 40. I mean, it looks like it's adding 20 there. Like this one right here. It looks like it's just adding that instead of subtracting it is what it's doing. But it's definitely subtraction because it's -2 squared and then times 5. That's 20, so it should be definitely -20. So whatever. I don't know. It's wrong. It's definitely 47. Anyway, so don't trust the calculator, honestly. Just do it in your own steps. So it's -27 over 3, which is -9, which also like just sounds right? -9, just like that just sounds right, you know. So anyway, we're gonna take that and we're gonna set it equal to the derivative, which is 3x squared minus 10x minus 17. And then from there, we're going to set that equal to 0. So we're going to add the 9. So we get 3x squared minus 10x minus 8. Yep. Okay. And then you got to factor this. So again, the factors are always going to be 3x and some x. And I want two numbers that multiply to get -8. They add to get -10, but I get to multiply one of them by 3. So these are kind of brain teasers. I got it. It's -4. Wait, look a second. Yes, it's -4 here though. It's -4 here, and it's a +2 here. I got that because I started playing with the factors of 8. And so using my 8, I was like, okay, 1 and 8 and 2 and 4, those are really the only factors I can do. And I was like, okay, well, 3 times, like this one's like just not going to work because it's going to be like 11, or it's going to be like 5, or it's going to be 24, it's going to be 20. You see what I'm doing, right? I'm basically just multiplying them by 3 and then like adding and subtracting the opposite one to see what I can get. And then I'll try 2 and 4. It's like 3 times 2 is 6. 6 plus 4 is 10. That would work if it was positive 10 though, but I want -10. So it's 3 times 4 is 12, right? -4 is 12. Plus the 2 is -10. That's how I got that. And you can do it. We can do this method too, like to help you just test them out. But you're basically going through the factors of them and just seeing which ones match when you multiply one of them by 3. Anyway, we're here. Solutions x equals 4. And this one again, 3x plus 2 equals 0. And c minus 2 minus 2. 3x equals -2 divided by 3 divided by 3. X equals -2/3. So I've got two solutions right now, but you want to look at the interval before you submit. And here it goes from -2 to 1, so I cannot include the 4 because it's outside it, so it's just going to be -2/3. It wants me to do this. So let's make sure I'm right here. Otherwise, I'm going to look like a Muppet. So I'm saying it's -2/3. Yay! All right. So that's that one. This is the same thing, guys. You get the you get the AROC. It's midnight, guys. It's Sunday, 12:11. Can you see my? I wonder if you can see that down there. Yep. Here we go. You work hard, I work hard, guys. No days off here. X squared minus 3 cosine 2x. You got to get the AROC first. So AROC is function y1 2 minus function y1 0. Divide that by 2. What's my AROC? So something you can do. I haven't done this in a while, but you can store this because I saw people kind of struggling with getting the right decimal places. So to make sure it's totally 100% accurate, you can store it with STO. So it's down here, STO, and then do alpha, and then like any letter, just do A. So then when you go plot it, right here you can just do A, because A is that solution. Does that make sense? So you find the average rate of change, and then whatever that was, you do STO. So it's just down here, and then the letter, and then you can just put that in. And here, like in y1, I don't want to put this. I think that's another mistake I'm seeing. Like you don't want where the function is that. You want where the derivative is that. So it's actually going to be the derivative is, in this case, this is like a different problem. The derivative is f prime of x is 2x plus 6 sine 2x. Okay. So I'm gonna put that in instead. So 2x plus 6 sine 2x. Yep. Okay, now I'll graph it, but make sure it's on the interval. What's the interval? 0, 2. I think I'm on 0, 2. There's two solutions right there. I'm on like -1 too, but it's fine. So I'll do intersect. I want nearest thousandth. Okay. Then I'll go. There it is there. Enter, enter, enter. 0.342. Right, it's the x value you're looking for, not the, it says right here 0.342, 0.342, and then the other one. So go to the other side. I think there's an easier way to do this than what I'm doing, but you know. Okay, there we go. 1.435. Okay, so we're going to add an answer here. 1.435. 1.435. Submit that. Hey, yeah. Okay, that's exactly what I did. Just what it says here. Okay, I mean, they're pretty straightforward. Just keep doing that. Practice that. Get good in the calculator. I might as well keep going. Let's go crazy, guys. Keep going here. These are pretty easy. So remember, average value is just like the area divided by. Average value is just area divided by the width. So for this one, you just add up these areas and divide it by the width of it. That's it. So we got 5 minus 7, right? 5 minus 7 minus 13. I think it's -15. Yeah, I think it's -15. And then divide that by 13 because the width is 13. So that's what I'm getting. -15 over 13. Seems a little weird, but let's see. -15 over 13. Hey, easy. These are super easy. Okay. Again, that's what it's saying here. This is a much better way of explaining it than me, but like you're basically you are taking that area, which is the integral, right? And you're just dividing it by the width. That's all it is. These are easy. I think you guys did fine with these. You just like the average rate of change from -99 is like this line right here, which is decreasing. And the average value, you just look at the areas. See all this negative area down here? Like I know it's negative because of all this negative area. So they're both negative. Where's that one? There we go. And I'll show you the picture of it. You can see here, right? Decreasing average rate of change and that negative average value. Both are negative. Okay. Yeah, this one. Yeah, this one's worth doing. This one's worth doing. Some of these are kind of tricky. The function f is defined by f of x is x squared minus 4 minus 2 yada yada. What is the average value of f prime? So you know what the formula is for average value, right? Formula for average value you know is like 1 over b minus a integral a to b of what and then something, right? So it depends what's what, right? What you're trying to find the average value of. If I was trying to find the average value, of f of x, this would be f of x right here. But I'm not trying to find the average value of f of x. I'm trying to find the average value of prime of x. So in here, we actually put f prime of x dx. So you kind of have a few options here. You could just get the derivative, which is 2x 2x minus 2 cosine x minus 3. You could just do this because that's f prime of x. So you could just do the integral from -3 to 1, 1 over 4 that. Like that'll do it. Because it wants the average value of the derivative, not the original. That might be the easiest way for you guys to do it. So should I show you that? So you would just go here, go to y equals, you plug it in, 2x minus 2 cosine x minus 3, and it's in y2. So then I'll do math 9, y2, comma x, comma, -3, comma 1, then divided by 4, -1.406 would be my answer. -1.406. -1.406. Yeah. Okay. See, the way they did it is different. They use fundamental theorem of calculus part 1, which just says that like you can just take the antiderivative of f prime, which is f of x, which we're given, and then take the difference between 1 and -3. And they got the same thing. Okay. Let's see what other problems we have here. This is the same kind of problem. Let's look at the problem types. Average values. This is just straightforward. Like, it's just, you know how to do this. You plug that into y1. You do what I just did in the calculator. You don't have to change anything. Average rate of change. You're just going to use the quotient formula, not the. Just make sure you read it very carefully. Average rate of change is not average value. It's different, right? A rock is f of b minus f of a over b minus a, versus a value is 1 over b minus a integral a to b f of x dx, right? Make sure you know the difference between these two. So if you see a rock, you do the a rock formula, right? B minus a. Average rate of change. So that's pretty straightforward. We already went over that one. These two I haven't gone over. This one is it's kind of similar to what I did. What is the average rate of change of f prime? It's like you get the derivative of it, and then you plug these values into the derivative instead of plugging into f. So just make sure you pay attention to what you're taking the average rate of change of. This one, yeah, this is like similar. It's just like with an integral. This is in an FRQ I gave a while back. You just plug in -1 into this, so you're taking the integral of this at 5, then the integral of this at -1, and then dividing it by 6, and that'll get you the average rate of change. Should I do that? Do you want me to like explain that? Okay. I feel like I know which one was saying yes, please explain that, in class. So basically, this is just like saying g of 5 minus g of -1 over 5 minus -1, so it's all over 6, right? So we need to find what is g of 5 and what is g of -1. And the way we do that is we need to take the integral of that function over this period. So we're going to do x squared minus x cosine x. Okay, and then we'll math 9 that at y1 from -1 to 5. Sorry, -0 to -1 will be the first one. 0 to -1. 0.6209. That's -1.6209. And you can do again, I'm going to do the thing here to get the exact value. I'm going to store that under A, so I can say that for later. And then same thing with g of 5. I'm just going to plug that back in. Plug in a 5. And I'm going to store that too. So that in B. Okay. Yep, -13.708 roughly. But like the storing thing is going to make sure I get like a really accurate result. So I'm just going to do here alpha A minus alpha B equals, wait, did I do that right around? No, other way around, sorry. The other way around, it's alpha B minus alpha A, is -13.087. So let's see, that's, don't forget, divide by 6. -2.181. Let's see, -2.181. Done. Okay, so that's that. Units, these aren't too bad, like once you understand them. I guess that can be said for everything, huh? Okay, let me get a piece of paper for this one. So, let's talk about units for a second. I'm gonna go, I don't know if I'm gonna go over this at any point. I don't know if I'm gonna go over this at any point besides right now, but this is how units work. So basically, like, you have like the function in the middle, and let's just pretend it's like, I don't know, feet per minute, right? And this is like the integral of f of x dx, and this is the like derivative of x, and this is like, I'll do another derivative here. Basically, as you go to left, it just like that one goes away. You kind of like lose the denominator, and as you go to the right, the denominator gets squared. And it's not about it being like time or whatever. Like it doesn't really. Uh, I'll give you like an example of this. Sometimes like the AP test really like messes you up by like saying like, oh, it's like actually hours per like gallon. Like it'll actually give you in those terms, and then it's like hours is in the numerator. So you gotta be like, really careful. Sometimes they trick you like this. Same thing, right? And then this would just be hours. So that's another way to trick you. Also, like sometimes they do this. Like they'll put this as like just hours per gallon, right, or something like that. And so this one's like hours, and then this one's hours per gallon squared. I don't know. They do stuff like this too, right? It's like it doesn't necessarily have to be like this is like the feet per minute or this hours per gallon. Sometimes like, it's like they put that one over as a derivative, and like the function is just hours. Um, okay, so that's basically the key to this. So let's speed through some problems here. The differentiable function f measures the rate of change. It's the temperature, the rate at which the temperature is changing. Okay, so basically, it's like here, and it's saying it's Fahrenheit per hour, so that my derivative would be Fahrenheit per hour squared. Done. All right. Atmospheric pressure. Um, the height above sea level. Yeah. See, it's not a rate. This is one of these ones. F of f of p is not a rate. It's just like a quantity. It's just height. See that? It's just the height above sea level can be measured by the differential function f of p. So therefore, the derivative is this one. So it's going to be uh, feet per psi. Do one more. Position. Same thing. If it's position, it's not a rate. It's just like the unit. So it's just giving me feet right now. So this is going to be feet per minute squared because I'm moving like 2 to the right because it's going from like the function to the second derivative. It's going to go from feet to feet per minute to feet per minute squared. So I guess like the also like another kind of helpful thing is like the inside is the denominator. Like with the t is time, time is the denominator, right? Um, okay, I think we got the gist of that one. Context questions. These are great. These are honestly my favorite questions, and I gave you these for a reason. Because it's like a lot of the FRQ problems just look exactly like this. And if you can answer these, you can do a lot of stuff. Um, during the time interval 0 to 4, the rate at which people are entering Switzerland, yada yada yada. Okay. I mean, this is just take the derivative of this at 3. That's all it is. That's all it's saying. So you just do math 8 in the calculator. You guys know how to do that. Put that in y1, math 8 it. That's it. This one, Yeah, okay, this is just average value. This is what we've been doing. So again, put down y1, math 9, average value, done. These aren't bad. I don't know what these are. You shouldn't have trouble with these. Um, yeah, this is a good one. Yeah, this is classic. Yeah, this is like on the last test. This is like a rate in problem. You have this as your starting amount, um, and then you're going to integrate this value in y1 from 0 to 11. That's it. Okay. And you're going to add those two together. This is very similar. Oh, the other thing to be aware of this one is just like, make sure you're like paying attention to this. This is people per hour. Because it's like, it's a total number. So it's like kind of the same thing as this one. It's like, you have to use the unit part of it as well. But this is just math 8. You can do that. Oh, this is kind of nice. I kind of like this one. This one is not asking you to find um, like the amount of t. It's just like how much more are there in t than 0. So you find the number at 2, and then you would just subtract this. So it's just like it's just a change. This is just the integral of this over 0 to 2. Um, yeah, okay. I'm not. I really think you should really get these. So I'm not worried about these. I think the only ones that I'm worried about, honestly, the kind of the first one was kind of the toughest one. These are not bad. That's not bad. They're time consuming with the calculator. And just read this one really carefully. This one's kind of tricky. You just got to read it carefully. Okay, we're gonna call it here, guys.